10.3 using chords. I'm going to go through this pretty quickly, all right? If you want to, on the video, just go ahead and go to half speed or slow it down. Make sure to pause when I say to pause, write down the things that I tell you to. Take the notes when you need to, all right? So first we're going to go through a couple of different theorems. So make sure to jot those down, and I'm going to go through them real quickly, but make sure to pause it and actually write it down, okay? They're also in your book, so if you need to take a look at that, write them down from your book if you can't see them up here. The first one would be the congruent corresponding chords theorem. So in the same circle or in congruent circles, two minor arcs, so like for instance A and B and C and D, those would be congruent if these chords are congruent. So if these chords are congruent, that means that the arcs are also congruent. Next thing is the perpendicular chord bisector theorem. All right, so that would say that if we've got a diameter and it's perpendicular to a chord, that means that it would bisect this chord exactly in half. That's going to be important further down the line here. Similar thing, if we've got a perpendicular chord bisector converse, so if we've got a chord here and it's bisected, so both sides are congruent, and it is perpendicular to another line, that means that that other chord that it's perpendicular to has to be the diameter. So again, jot those down if you haven't already. Example 1, go ahead and draw these circles in your notes, and I'm just going to get into it, so pause it, write it down, and then we're going to get into it, all right? So first thing, we need to know that we've got two separate circles. How do we know that they're congruent? We know they're congruent because the radiuses are congruent, all right? Again, if the radiuses are congruent in a circle, it means that the circles are congruent. All right, we just need to find the measure of arc, FG, and again, notation is important. Make sure you have an arc up here, not a segment. All right, we'll see notation later down the line. It's going to be really important that we see it this way. All right, since these are the same circles and these chords are congruent, that means this has to be 80 degrees as well. Again, if we're talking about the measure of an arc, so like measure of FG, it's similar to when we were talking about the measure of an angle. We're talking about the angle measure. All right. Example 2, using a diameter. All right, again, go ahead and pause this, jot this circle down. So they tell us that this arc is 11x, this is 70 plus x, this segment here is 7. All right, and this is where notation is very, very important. Letter A, so again, pause it, write things down if you haven't already. Letter A, we need to find HK. All right, here we've got a diameter and it's perpendicular to this chord, that means it bisects the chord. All right, so in this case, if NK is 7, that means that HN also has to be 7. It's bisected, right? So then HK, we're not done yet. HK is the full thing. 7 plus 7 is 14. All right, again, that's notation, right? Notation tells us that we're looking at a segment and not the measure of an arc, angles. All right, letter B, however, we are. This is, again, why notation is important. Measure of arc HK. All right, now we're looking at this arc, so we're looking across the edge of the circle. All right, what I see here is, well, we've got this arc here, right? It's split into two congruent arcs, right? We know that they're congruent because these two are congruent as well. All right, so that means that this arc has to be congruent to this arc. All we're gonna do is we're just gonna set these two equal to each other. 11x equals 70 plus x. Get all your variables to one side by subtracting x. We get 10x equals 70, and you divide by 10, x equals 7. All right, now is that the measure of arc HK? No, it's not. It's just the measure of one part. All right, we just have to plug that into either one. All right, when we do that, we find that half of it, so for instance, measure of arc HJ is equal to 77 degrees. Multiply that by 2, now we get 154 degrees, and that is the measure of arc HK. Again, feel free to slow it down, pause it when you need to. All right, think about the question before you actually write things down. We'll just go through these here real quick, all right? We've got the same circle here. These two chords are both equal to 9. That means they're congruent. This would have to be 110 degrees as well. If we were to find the measure of this red arc, so red chord here, this is, again, just a partial chord, but we can figure it out because we know that we've got a diameter. It splits this in half because it is perpendicular to it. We just set these two pieces equal. X plus 5 equals 2x plus 6. Again, you're just going to do some simple arithmetic. When you do that, you get x equals -1. And you haven't found it yet. You still need to plug this in. 2 times -1 is 2, or -2. -2 plus 6 is equal to 4. All right, so in this case, and I should use proper notation on that, shouldn't shorthand it, BF equals 4. All right, this one here, all right, again, we've got a diameter, and we've got this chord here that's perpendicular to it, which means that these two are congruent, which also means that these two have to be congruent as well. So then we just take 9x, set it equal to 80 minus x, add x to each side, we get 10x equals 80. X must be equal to 8. We're not done yet. Plug that in. 9 times 8 is 72. 72 times 2 is 144 degrees. So measure of arc CE equals 144 degrees. Alright, so we're just about done here. One more example. So here we've got equidistant chords theorem. All this says is that if we've got two chords and these two segments are perpendicular to them, that means that they are equidistant from the center. All right, example 4, using congruent chords to find a circle's radius. So in the diagram, they tell us, and this is going to be important, so you kind of have to look through the information that they give us. QR, that would be this segment here at 16. ST is also 16. We have to find the radius of circle C. So they give us some more information, but that information can be found in the diagram. So note we have two chords here, and these two segments, they are perpendicular to the chords. That means that these two chords have to be the same distance from the center C. So that means we can set this 5x minus 9 equal to 2x. And then again, I'm not going to write down the arithmetic, but we end up with 3x equals 9. Make sure to show your work when you're actually doing this. And then when we solve, divide by 3x is equal to 3. All right, now we can find each of these side measures. So this, in this case, 2 times 3, this would be 6. So we've got a side that's 16, and this whole thing is, or a side that's 6, and a whole side is 16, which means each of these pieces would be 8. All right, now we're interested in finding the radius. We're going to go back to triangles here to connect the circle, so the center of the circle, to the edge. Now we've got this perfect right triangle. And what can we use to find the missing side of a triangle? Well, if we've got two of the sides, it's simply going to be Pythagorean theorem if we've got a right triangle, and we do. All right, so in this case, we're going to take 6 squared plus 8 squared, right? We don't know the radius, so we're going to call that just r squared. All right, when we do that, 36 plus 64 is 100 equals r squared. So r would be equal to 10. All right, that's our final answer. Pythagorean theorem, chords, all of that. That's it.